All right, so this video is on identifying proportional relationships. I can see my little face floating over there. Let me move this around a little bit. Okay, let's see if I get my face. There we go. Now you can see me. All right, so it says apples are on sale for $3.12 per kilogram. Is the total cost of the apples proportional to the total mass? And what you can see here is it very clearly says they're on sale for $3.12 per kilogram. Mass is kilograms, right? So you have a price per kilogram, right? That's what you have. And every single kilogram weighs a kilogram and costs the same amount, right? Price per kilogram. So really what we have here is 3.12 all over 1, right? $3.12 for every 1 kilogram. And that's going to stay constant throughout the entire relationship. So like if you were to buy $6.24 for 2 kilograms, and so on and so forth, right? So no matter how much you buy, it's always going to cost $3.12 per kilogram. So that means that if you bought no kilograms, like no weight at all, it's going to cost you nothing. So it starts at 0, 0, and it increases at a constant rate. The ratio of y over x is always going to be the same, 3.12 over 1, or 3.12. The equation would be 3.12x. That equals y, and that's it. You're done. So this is a yes. For the next one, it says you are making lemonade. The amount of sugar you need depends on the amount of lemonade mix you use. So here you've got cups of sugar and packets of lemonade mix. It doesn't matter which one you put as your top, which one you put as your bottom. You're just looking to see if the ratio stays constant. So if you have, let's say, packets of lemonade mix as your input and cups of sugar as your output, then you'd be looking at sugar on top, and you have lemonade mix on bottom, right? So you got this ratio of sugar to lemonade mix, right? And if that's the case, you've got a ratio of 1 over 1/3, or sorry, 1/3 over 1. So this is the ratio, right? For every packet of mix, you should have 1/3 cups of sugar. And if that ratio stays constant, you have a proportional relationship. Is that the same as 1 over 3? Is that the same as 3 over 9? Are all of these ratios constant? In other words, is the ratio of sugar to lemonade mix always the same? When we investigate this, we can see that here you just multiply top and bottom by 3 and you get the same value. So that's a definite yes. And then to get to this one, all you got to do is take this value and multiply top and bottom by 3. And so that's also a definite yes. So that ratio is staying constant. All those ratios are the same. Therefore, it's a yes. Okay, for the next one, Cam is a corrupt politician. Nobody votes for him except those he pays to do so. It costs Cam exactly $100 to buy each vote. Are Cam's costs proportional to the number of votes he receives? It says nobody votes for him except those that are paid to do so. So because no one votes for him, if he doesn't pay anybody, he has no votes. So the number of votes to the dollars is always going to be starting at 0, 0, right? He gets no votes unless he pays people, so he gets no votes for no dollars. That's a really important thing, because if he's getting any votes, okay, when he puts out no money, then it wouldn't be proportional. But because of the fact that he's getting no votes outside of the ones he bribes, it is proportional, because it says it costs exactly 100 for every vote he buys. So then it means basically you're looking at y equals 100x, where x is the number of votes he buys, the y is the cost in bribes, and then the 100 is the multiplier, right? So this is always going to be a ratio of 100 over 1, right? $100 for every vote. So it's a yes. The next thing says, does the following table show a proportional relationship between the variables of x and y? So once again, I don't really know what these categories are. It doesn't matter. All that matters is that the ratio of y over x is always the same. So you just ask yourself, is that ratio of y over x always the same? Is 3 over 1/4 the same as 6 over 2/4, the same as 9 over 3/4? Right? Is that ratio always the same? If that ratio stays constant, you have a proportional relationship. So the way I would investigate this real quickly is I would just say, okay, well, dividing by 1/4 the same as times by 4. So 3 divided by 1/4 is 12. 6 divided by 2/4 is the same as 6 times 4 over 2, which is going to be 24 over 2, which is also 12. So that's a yes. And then on this one, you've got 9 divided by 3/4, which is the same as 9 times 4/3, which means that you're going to have 9 times 4 over 3. 9 times 4 is 36, over 3 is 12. So you have a 12 again. So are all of these ratios the same? Yes, they're all worth 12. What will be the equation for this relationship? Y equals 12x. And there you go. X times 12 equals y. What's 1/4 of 12? 3. What's 2/4 of 12 or half of 12? 6. What's 3/4 of 12? 9. And so this is definitely a proportional relationship. A movie theater, what does it say here? A movie theater charges $10.50 per ticket and $5 per bucket of popcorn. You never buy the popcorn because you think it's too expensive. So you never, ever, ever buy the popcorn. So the only thing you're paying is $10.50 per ticket. Is the total price you pay proportional to the number of tickets you buy? Well, since you're not buying popcorn at all, and the tickets are always $10.50 for every ticket you buy, the answer is yes. If you were to buy popcorn occasionally here and there, then it wouldn't be proportional because your total cost would include popcorn sometimes. But in this case, it never includes popcorn, and it's always $10.50 per ticket, so the rate stays constant. So it's yes. Does the following table show a proportional relationship between the variables g and h? Okay, it doesn't matter which is your x and which is your y, but the concept here is that does the ratio stay the same? So let's just pick the larger one because it's easier to do the larger one divided by a smaller one. So let's just say h over g. Is that ratio constant? Is 9 over 3 the same as 36 over 6, the same as 81 over 9? What's the value of that ratio? Well, 9 over 3 is 3, and 36 over 6 is going to be 6, and 81 over 9 is going to be 9. So are these constants the same? Are these multipliers the same? No, they are not. This is a no. And the next one says, Jimmy receives his first 3 video games for free and then pays $50 for each game after that. Is the amount of money he spends on video games proportional to the number of games he owns? And the answer is no. If you were to make a table for this relationship, he gets his first 3 games free. So does it start at 0? Yeah, it starts at 0, 0, right? So if he has no games in his library, it costs him no money. Fine. Assuming this is the only place you buy games, which is not even really what it's saying, because it says all the games he owns. Maybe he bought games other places that are even outside the story. This is not a great question, but definitely not proportional. I'll explain why. So 0 games cost him $0, right? Okay, that's a good start, 0, 0, right? But then watch. The first 3 games that you buy cost nothing. They're free. Then it says $50 per each game after that. So the 4th game in his library means he spent $50 for that. The 5th game, he would have spent $100. And then the 6th game, he would have spent how much money? $150. So you can see here that if you're looking at the ratio of the amount of money he spends on video games proportional to the amount of games he owns, if he has 6 games in his collection, it costs him $150. He has 5 games in his collection, it costs him $100. He has 4 games in his collection, it costs him $50 only. But if he only had 3 games in his collection, it would all be free. So is this ratio of price per game constant? No, right? If the next time he buys a game, it's going to be 200, right? So every game he buys from this point forward is going to increase the price per game, right? And the first games were all free. So the ratio is not constant. I mean, I could very obviously show you that, right? 50 divided by 4 is the price for each game at this point. Then here, 100 divided by 5 is the price per game at this point. Then 100 divided by 6 would be the price per game at this point, and so on and so forth. These ratios are not constant. So that's kind of how it works. And it'll be approaching $50 per game eventually, right? After his initial discount eventually goes away to be nothing that valuable anymore. So this is definitely a no. The rate is not constant. He doesn't pay the same price for every video game. He very clearly pays different prices for the games because it starts at 0 and then it goes to 50. All right, that's it. So that's how you do the problem.